In this video, we're going to talk a little bit about Type 1 and Type 2 errors. A Type 1 error is when you reject Ho, the null hypothesis, when it is in fact true. A Type 2 error is when you fail to reject Ho, when in fact it is false. Let's consider the following scenario. A potato chip factory supervisor wants to know if the company's product is being packaged correctly by weight. Each bag is expected to contain 10 ounces of product, but the factory supervisor suspects that one of the machines may be overfilling the bags. A test of the null and alternate hypotheses, Ho, where mu is equal to 10, versus Ha, where mu is greater than 10, yielded a p-value of 0.037. Using a significance level of 0.05, the null hypothesis is rejected. Is the supervisor correct to reject the null hypothesis? Yes, the supervisor is correct to reject the null hypothesis. Because our p-value is less than our significance level, 0.05, the supervisor should reject the null. Suppose a significance level of 0.01 is used. Is the supervisor still correct to reject the null hypothesis? In this case, no, because the p-value of 0.037 is greater than the significance level of 0.01. And when your p-value is greater than your significance level, you fail to reject the null hypothesis. Now let's assume a Type 2 error is made. Who might benefit? The company or the consumer? If a Type 2 error is made, that means that we have failed to reject the null hypothesis when in fact the null hypothesis is false. So in this case, a Type 2 error would occur if the potato chip factory supervisor determined that mu was equal to 10, or in other words, that the bags were not being overfilled when in fact they were being overfilled. The consumer would benefit from this particular error. So there is just a brief example on how Type 1 and Type 2 errors might be used in a statistics problem. I hope you found it helpful, and we'll see you next time.